Evaluate limit as x approaches 0 of sine of x minus x all over quantity e to the x minus e to the negative x minus 2x. Okay, so first thing we do is we plug in 0 and see what happens here. So we have sine of 0, which is 0, minus 0 for x, which is 0. E to the 0 is 1, minus e to the negative 0, which is also 1, minus 2 times 0. Okay, and we do get an indeterminate form. We get a total of 0 over 0. So this is L'Hopital's rule. So L'Hopital's rule, the idea is if you have an indeterminate form, 0 over 0 or infinity over infinity, then you take the derivative of the top, derivative of the bottom, take the limit to the same limit, and the answer you get will be the answer to the first one. So to show you what I mean, we have then a limit as x approaches 0 of derivative of sine of x is cosine of x. That's just something that has to be memorized. Such is life. Derivative of x is e to the x. Derivative of e to the negative x is e to the negative x divided by negative 1, which will make that a positive, minus derivative of 2x is 2. So if we plug in 0 again, we get cosine of 0, which is 1, minus 1 over e to the 0, that's a total of 2, 2 minus 2. This will then give us 0 over 0, and we still have an indeterminate form. So we just do L'Hopital's rule again. So we'll do this again, change colors to show that we are changing a thought process, or moving on to the next story arc. So then the derivative of cosine of x will be negative sine of x. And the derivative of, I don't like that n. I know, overly picky. There we go. All over. The derivative of negative 1 will just be 0 because it's a constant. So we'll have e to the x, and then we'll have derivative of e to the negative x will be e to the negative x divided by negative 1, so that negative comes back, and then that 2 disappears. Plug this in, we have negative 0 over 1 minus 1. So I have e to the 0 minus, man. Okay. I did not feel that there was going to be this many story arcs. It's kind of like a Dragon Ball Z saga where it's like, oh, it's finally going to end. No, it got another arc. It's like, oh, most powerful person in the universe. Well, we'll introduce multiple universes. It's like, okay. All right, focus. So we can do this. So the derivative of sine of x is cosine of x, but the negative sign is going to stick around, so we'll have negative cosine of x. And then we have e to the x plus e to the negative x. So e to the negative x is still derivative of e to the negative x, but we still have that negative 1, which then plays in there. And this time we get negative 1, because cosine of 0 is 1, all over 1 plus 1, which is 2. So negative 1/2. Ha-ha! Nice. Good for us. Go team. I can do a better box than that. There we go. So the concept here is, looking at big picture, we are given an equation. We're like, all right, find this limit. The limit is an indeterminate form, which is 0 over 0 or infinity over infinity. So we're like, okay, L'Hopital's rule. We do L'Hopital's rule, we get another indeterminate form. So, okay, that didn't quite work out. We do it again, still have an indeterminate form. And finally, we do it a third time, and something that's not indeterminate comes out. We get some actual numbers, so to speak. In this case, we got negative 1/2. So that's how you use L'Hopital's rule with something that kind of, you have to do more than once. Kind of an inception type thing. One after the other, finally get an answer. That's how you do this problem. I will see you on the next problem.